Alright, I'm going to do a second example here of simplifying radicals. So in this case I have the cube root of 54 times y to the 6th times x to the 7th. And once again, I always like to start with the number. So this time I want cube roots, so I want to know, are there any factors of 54 that are cube roots? Now let's say I think about this for a while and I can't think of any numbers that go into 54 that are cube roots. In that case, before I move on to the variables and give up on the 54, I want to create a factor tree off to the side. So for instance, let's say I write 54 off to the side here. Well, I know 54 is even, so I know 2 divides into 54. 2 will go into 5 2 times with 1 remaining, and then 2 goes into 14 7 times. Now at this point you might likely notice that 27 is a perfect cube, but even if you don't, you can keep going with the factor tree. 2 can't be factored any further because it's a prime number, but I can factor 27. 3 goes into 27 9 times, and then I can factor 9 into 3 times 3. Now notice what I can do here is I can write 54 as a product of its prime factors. So 54 is really equal to 3 to the third times 2. Okay. Now what this allows me to do then is I can come back up to my original problem and I can rewrite this as the third root of 3 to the third times 2 y to the 6th x to the 7th. Okay, I've rewritten the 54 as 3 to the third times 2. Now, what this allows me to do then is I can break apart a radical that's all multiplication like this on the inside as a bunch of mini radicals being multiplied together. So for instance, I can think of this as the cube root of 3 to the third times the cube root of 2 times the cube root of y to the 6th times the cube root of x to the 7th. Okay, so notice I've broken up the multiplication each into its own cube root radicals, all being multiplied together. Well, if I cube a number and then take the cube root of that number, the cube and the cube root will cancel and I'll just be left with that number. So the first one will simplify as just 3. Next, if I look at the second radical, notice I get the cube root of 2. Well, that can't be simplified, so I'll just leave it as the cube root of 2. If I look at the third one here, I have the cube root of y to the 6th. Notice that 3 goes into 6 2 times with none remaining, so I get y squared on the outside and the radical goes away. And then lastly here, if I look at this last one, I have the cube root of x to the 7th. Well, 3 goes into 7 2 times, so an x squared comes out. But I'll have 1 remaining, so I need to leave 1 x remaining. Now this is important to remember, and this is something I forget a lot. When you leave this 1x underneath, you need to also remember to keep your index sign. This should still be the cube root of x. And then lastly, we just have one last step here. We just need to combine the things under the radicals together and then put the things on the outsides next to one another. So for instance, this should say 3 times y squared times x squared times the cube root of 2x. This would be the simplified form of this example.